friends, here we have to prove that the function f from set of natural numbers to natural numbers defined by fx is equal to x square plus x plus 1 is 1 1 but not on 2. So first I will prove how we can prove it as 1 1. So for 1 1 we always have to assume two elements in domain. So let x1 x2 belongs to set of natural numbers such that if we are able to prove this such that f of x1 is equal to f of x2, then the function is 1 1. So here let's use this function definition given in the place of fx1 fx2. So this is x1 square plus x1 plus 1 is equal to x2 square plus x2 plus 1. Now let's shift x2 square on the left hand side. I get x1 square minus x2 square plus x1 minus x2 is equal to, and this one when goes to the left hand side minus 1 gets cancelled and we are left with 0. This is a square minus b square. It can be written as x1 plus x2 into x1 minus x2 plus this left out x1 minus x2 is equal to 0. Now we can take this common from this and this expression. So if I take out x1 minus x2 here, I am left with x1 plus x2 plus, when nothing is there, 1 is there because we have taken this completely outside, is equal to 0. Now from this equation what is clear, that this expression is not equal to 0 because x1 x2 has to be from the set of natural numbers and already plus 1 is there, so definitely this bracket will never be 0. So this will be 0, so I will compare x1 minus x2 with 0, which gives us x1 is equal to x2. So for every x1 x2 belonging to set of natural numbers such that fx1 is equal to fx2 gives x1 is equal to x2, it means that the function is 1 1. Thank you. Let's prove the function is onto or not. So here for that, first we assume let y belongs to fx. That means y is an element of codomain such that fx is equal to y. If we are able to prove, then it is onto. So y is in the form of x. Now we will try to write x in the form of y. It is the general process of proving any function to be onto or not. So here first write x, then divide the coefficient of x by 2, which is 1 by 2, and put whole square plus 1 as it is, minus always subtract the square of this. So square of this is 1 by 4, which is subtracted from this one. Okay, now when I find the LCM, it is 3 by 4, and 3 by 4 when shifting to the left hand side is y minus 3 by 4 is equal to x plus 1 by 2 whole square. And find the LCM, 4y minus 3 by 4 and x plus 1 by 2 whole square. Take the square root, 2 is left in the denominator, and then this 1 by 2 is shifted to this side, minus 1 by 2 is equal to x. And when we find its LCM, I get under root 4y minus 3 minus 1 upon 2, because both the denominator is same, we don't have to do much. But is it true? Is it true? That means does it hold true that for every y in codomain does x exist in domain? No, the answer is no. Why? Because if I put y is equal to 1, sorry, if I put y is equal to what shall I put? So if I put see that if I put y is equal to 1 over here, I get 4 minus 3, which is 1, and square root of 1 is 1, 1 minus 1 is 0, so I get x is equal to 0. So but x does not exist in domain because x contains all natural numbers as per the given definition of the function, that f is from n to n. This is the definition. So domain is natural numbers and codomain is natural number. So if I am putting 1 from codomain here, what I am getting element in domain? 0, which is not true. So for every y in codomain, there does not exist x in domain. There does not exist x in domain. This is very important condition to be mentioned in bracket when you are declaring this not onto, because value of x is 0, which is not in domain. Similarly, if I put 2 in the place of y, 4 2s are 8, 8 minus 3 is 5, square root of 5 is somewhere 2 point something, and when I subtract 2 point something with 1, I get answer in 1 point something. So the numerator is small and denominator is greater. Again I'll get value for x in decimal form, which is again not in domain, so it is not onto, because the condition for onto is for each and every element of codomain there should be a pre-image in domain. Thank you.